Beneath the familiar blue of our oceans, entire continents are hiding in plain sight. Scientists have now traced the remains of 20 lost continents buried under the seafloor, a discovery that completely rewrites the story of our planet. By the end of this exploration, you will know exactly how these vanished lands were found and what they reveal about Earth's deepest secrets. We will uncover how a land bridge allowed the first humans to reach the Americas, and what mysterious forces caused a continent larger than India to sink without a trace. How do you think a lost world could change our understanding of history? These lost worlds vanish through forces operating on a scale almost beyond human comprehension. Picture a massive layer cake slowly settling in a pan of water. Over millions of years, the immense weight of a continent can cause the Earth's crust to thin and stretch, pulling the entire landmass downward until it is drowned by the sea. In other cases, tectonic plates collide, with one plate forced to dive beneath another, dragging entire sections of a continent down into the planet's fiery mantle. Add to this the dramatic sea level rises from melting glaciers, which can rapidly flood coastal plains and continental shelves, and you have the recipe for a world lost to the ocean. But how do we find these sunken giants? Scientists are like planetary detectives, using an array of sophisticated tools. Ships equipped with multi-beam sonar paint a detailed picture of the seafloor, revealing the sunken mountains and valleys of a drowned landscape. They pull up core samples, long cylinders of sediment and rock that act as a time capsule, preserving fossils and minerals that whisper of ancient rivers and forests. From space, satellites measure tiny variations in Earth's gravity field, which can betray the presence of a massive, dense continent lurking beneath the lighter oceanic crust. Institutions like the National Oceanic and Atmospheric Administration lead this underwater exploration, mapping these hidden realms and piecing together their stories. With this foundation of how continents sink and how we find them, we are ready to meet one of the most famous of all, a land bridge that forever changed human history. That land bridge connecting worlds was just a thin sliver of a much larger story. Far out in the Pacific Ocean lies a true lost continent, a place called Zealandia. You are likely looking at a map of it right now, but only its highest mountain peaks. The islands of New Zealand are merely the most visible part of a continent that is 94% underwater. For decades, scientists debated its true nature. Was it just a collection of islands or something far grander? The answer came from the rocks themselves. Research vessels drilled deep into the seabed, pulling up core samples that told a definitive story. Instead of the dark, dense basalt that forms the ocean floor, they found continental granite and sandstone, rocks that could only have formed in shallow seas or on dry land. These samples held fossils of ancient spores and pollen, the remnants of a lost world that was once teeming with life. Geologists now describe Zealandia as a fragment of the ancient supercontinent Gondwana. Around 80 million years ago, powerful tectonic forces began to stretch and thin this piece of crust, causing it to break away and slowly, inexorably, sink beneath the waves. New Zealand is all that remains above water, the stubborn highlands of a continent that refused to vanish completely. This discovery of a sunken continent right on our maps fundamentally reshapes our understanding of what a continent is. It forces us to look at the oceans with new eyes, knowing that the familiar blue can hide giants, and Zealandia is not even the largest of these submerged worlds. The discovery of Zealandia revealed entire continents could hide beneath the waves, but the ocean's secrets are not limited to massive landmasses. Scattered across the seafloor are the fragments of lost worlds, some so small they are called microcontinents. One such hidden shard is Mauritia, an ancient landmass now buried deep under the sands and waves of the Indian Ocean. Its story began not with a grand geological survey, but with a handful of sand from a tourist beach on the island of Mauritius. Scientists examining these ordinary-looking grains made an extraordinary find. Trapped within the sand were tiny, incredibly resilient crystals of zircon. These zircons were geological time capsules, and their internal clocks revealed they were over 2 billion years old. This was the puzzle. The volcanic rock that forms the island of Mauritius is only 9 million years old. How could a young island have sand containing the oldest minerals on Earth? The only explanation was that the sand held relics from a much older, hidden continent lying beneath the island. Mauritia was the answer. This microcontinent was once a piece of solid ground nestled between what would become Madagascar and India, when they were all joined together as part of the ancient supercontinent Rodinia. As the Earth's plates began to shift and pull apart, a massive plume of hot rock from deep within the mantle welled up beneath Mauritia. This intense volcanic activity stretched the crust thin, much like taffy, and ultimately shattered this fragment of continent. The larger landmasses of India and Madagascar drifted away, while the pieces of Mauritia were submerged, buried under layers of lava and sediment. One geologist described finding Mauritia as discovering a single piece from a billion-piece jigsaw puzzle of a planet we have never seen. By tracing the path of these zircon crystals, scientists can now model the shape and movement of Rodinia, a landmass so ancient it existed long before the dinosaurs, long before complex life itself. Each of these lost continents, from the vast Zealandia to the tiny Mauritia, is a crucial piece in the grand puzzle of our planet's dynamic and ever-changing history. The story of our planet is also written in the lands we lost to human memory. Between the familiar coastlines of Britain and the Netherlands lies a vanished world known as Doggerland. For thousands of years, this was not seabed but a vast, low-lying plain, rich with forests, marshes, and rivers connecting continental Europe to the British Isles. It was a thriving home to human hunter-gatherers who tracked herds of mammoth and deer across its gentle hills. We know they were there because archaeologists have made astonishing finds from the bottom of the North Sea. Fishing trawlers have hauled up not just fish but ancient stone tools and the massive, curved tusks of mammoths, relics of a landscape that vanished beneath the waves. Detailed sonar maps now reveal this sunken country in stunning detail, showing the winding paths of its ancient river valleys and the outlines of its long-drowned lakes. So what happened to this European plain? The end of the last ice age sealed its fate. As the global climate warmed, immense glaciers melted, causing sea levels to rise relentlessly for centuries. This slow-motion flood was dramatically accelerated by a single, catastrophic event. Around 6,150 years before the Common Era, a massive underwater landslide off the coast of Norway, known as the Storegga Slide, triggered a mega-tsunami. A towering wall of water smashed into the remaining coastlines of Doggerland, inundating the final refuge of its human inhabitants and submerging the land for good. This lost world forces us to confront a powerful reality. The coastlines we see on our maps today are not permanent. They are just a snapshot in time, shaped by the profound forces of climate and geology. Entire human histories are now hidden beneath the sea, a reminder that our own world is constantly, if slowly, being remade. The fate of Doggerland was mirrored on the other side of the world, where a much larger and more ancient land once bridged the islands of Southeast Asia. This is Sundaland, the drowned heart of a vast tropical realm. Today, its highest peaks form the islands of Java, Sumatra, and Borneo, but during the last ice age, when sea levels were over 100 meters lower, these were not islands at all. They were the rugged highlands of a single, continuous continent that stretched all the way to mainland Asia. Paleoclimatologists have pieced together a picture of a land dominated by dense rainforests, crossed by massive river systems that flowed across what is now the Java Sea. Evidence for this lost world comes from the very bottom of the sea. Sediment cores drilled from the seabed contain layers of ancient soil and pollen from rainforest trees, proving that this was once solid ground teeming with life. Even more telling are the drowned coral reefs found at depths far too deep for living coral, marking the old shoreline where the Sundaland coast once met the open ocean. This continent was not just a habitat for animals, but a major thoroughfare for our own ancestors. Genetic studies trace multiple waves of human migration across this now vanished land bridge. Early modern humans likely followed the coastlines and river valleys of Sundaland, moving from mainland Asia toward the lands that would become Australia and New Guinea. Their journey was shaped by the same climatic forces that would eventually erase their path. The regular pulse of the ice ages dictated Sundaland's existence. During glacial periods, water was locked up in massive ice sheets, exposing the continental shelf. But when the planet warmed, the monsoons shifted and the glaciers melted, causing a rapid and relentless rise in sea levels. This was not a single flood, but a slow, inexorable drowning that took place over thousands of years, gradually turning a vast continent into an archipelago. The incredible biodiversity we see in this region today, from the unique wildlife of Borneo to the deep genetic diversity of its human populations, is a direct legacy of this lost world. Sundaland stands as a powerful testament to how climate and geology can build a continent for humanity to explore and then reclaim it just as surely. This cycle of creation and loss did not only occur in the tropics, but also in the frigid waters of the far north, where a legendary land has haunted maps for centuries. That legendary land in the far north is more than a cartographer's fantasy. It was a real continent, a frigid gateway to a new world known as Beringia. For much of the last ice age, this was not a narrow bridge but a vast, dry plain, a continent in its own right that connected northeastern Siberia to Alaska. With sea levels over 100 meters lower, the floor of the Bering Strait was exposed, creating a landscape of cold steppe grasslands, 1,000 kilometers wide. This was no barren wasteland. It teemed with life, supporting massive herds of steppe bison, woolly mammoths, and giant elk, all of whom left their mark. Trawlers and scientific surveys have dredged up their fossilized remains from the seafloor, tangible proof of a lost ecosystem that thrived where only ocean currents flow today. This continent was the crucial corridor for one of the most significant journeys in human history. Anthropologists describe Beringia not as a mere crossing, but as a homeland for generations. The first people to enter the Americas did not sprint across an icy corridor. They likely lived and hunted in this region for centuries, adapting to its unique environment before moving deeper into the continents that lay to the south. DNA evidence from indigenous populations across the Americas provides a powerful genetic trail, all pointing back to ancestral founders who once called Beringia home. This land bridge is a profound reminder of how fleeting our world's geography can be. Its existence was entirely dictated by the global climate. When the Ice Age ended and the glaciers melted, the rising seas poured back into the shallow Bering Strait, slowly flooding the plains. The continent vanished, severing the land connection between the Americas and Asia, and isolating the peoples of the New World for thousands of years. The story of Beringia shows that a continent can appear and disappear, fundamentally reshaping the course of human history in the process. Yet some of the most astonishing lost continents were not bridges at all, but entire worlds that sank into the deepest, most isolated parts of the ocean. Far from any human shore, in the frigid, storm-lashed waters of the southern Indian Ocean, lies the Kerguelen Plateau. This is not a continent of granite like Zealandia, but a colossal volcanic giant, a microcontinent forged entirely from fire. Stretching for over 2,000 kilometers, it is one of the largest volcanic plateaus on Earth, yet almost all of it lies more than a kilometer beneath the waves. Its story began around 100 million years ago during the age of dinosaurs, when a mantle plume of superheated rock erupted through the ocean floor. This was not a single volcano, but a cataclysmic, prolonged event that poured out enough lava to build a landmass nearly the size of Australia, a titanic version of how Iceland is forming today. For millions of years, this fiery birth created an island vast enough to develop its own climate and ecosystems. How do we know this isolated plateau was ever above water? The proof was pulled from the deep. Scientific drilling expeditions have plunged their bits into the submerged plateau, retrieving core samples that are nothing short of time capsules. The basaltic rock told one story, but nestled within were fossils of ancient pollen and fragments of wood from conifer trees. These delicate remains confirm that the Kerguelen Plateau was not always a sunken fortress. It was once a verdant, forested land, likely home to unique species that evolved in complete isolation, a lost world in the middle of a vast ocean. Geologists see Kerguelen as a natural laboratory. Its formation from a hotspot blurs the line between a standard volcanic island chain and a true continent. It challenges our definitions, showing that under the right conditions, massive outpourings of lava can create a crust thick and buoyant enough to rise above the sea, forming a unique type of continental fragment. The story of this volcanic giant demonstrates that continents can be born from immense geological violence, rising from the ocean floor only to be gradually reclaimed by the waves through subsidence and erosion. This fiery origin story beneath the southern seas points to an even more dramatic process, one that can shatter existing continents and scatter their pieces across the globe. The deep ocean holds remnants of lands shattered by the planet's restless motion. North of Iceland, hidden beneath the dark, icy waters of the Arctic Ocean, lies the Mayen Microcontinent. This fragment of continental crust was only recently identified, not by a visible landmass, but through the subtle whispers of seismic waves and the hard evidence of rock samples pulled from the seabed. The story these rocks tell is one of a dramatic divorce. The Mayen Microcontinent was once a solid part of eastern Greenland, firmly attached to its ancient coast. Then, roughly 50 million years ago, the powerful forces of seafloor spreading began to tear the Earth's crust apart. A new oceanic ridge formed, acting like a geological zipper that slowly and inexorably pulled this block of land away from Greenland, creating a new basin of ocean floor between them. This process left the Mayen fragment isolated and adrift, a geological orphan in the freezing Arctic Sea. The most compelling clues to its past, however, are not just in its structure, but in what it once supported. Buried within the core samples, scientists found evidence of ancient river systems and, remarkably, coal deposits. Coal forms from compressed plant matter in swampy environments, meaning this now frigid microcontinent was once a verdant, temperate landscape, possibly covered in forests. It was a world of flowing rivers and lush greenery, a stark contrast to its current state of perpetual winter and deep submersion. Geophysicists working in the region often express that discovering Mayen is like finding a crucial missing page from a ripped-up history book. One researcher noted that this single microcontinent provides critical constraints for our models, helping us reconstruct the complex tectonic dance that opened the North Atlantic Ocean. It clarifies the timing and the interactions of the plate boundaries, showing how Europe and Greenland finally parted ways. As we map these Arctic secrets, our search turns to lost lands in much warmer waters, where the sunken evidence points not just to geological shifts, but to the rise and fall of entire civilizations. A submerged mountain range snakes across the top of the world, a silent ridge beneath the Arctic ice. This is the Lomonosov Ridge, a 1,500-mile-long sliver of continental crust that stretches from Siberia to North America. For decades, its true nature was a polar mystery, debated by geologists who could only guess at what lay under the frozen sea. The breakthrough came from powerful icebreaker ships, which smashed through the thick ice to reach the ridge below. They drilled deep into the seabed, pulling up long cylinders of sediment that held a stunning secret. Within these cores were the fossilized remains of freshwater plants and even ancient peat. These were not the relics of a deep ocean floor. They were the remnants of a terrestrial landscape, proof that this entire ridge was once a land bridge, a temperate plain connecting two continents under a much milder Arctic sun. This discovery transforms our understanding of the far north. The Lomonosov Ridge was not always a deep sea feature. It was a continuous strip of land, a polar corridor that animals and perhaps even early humans could have traversed when sea levels were lower. Its submersion was a dramatic event. Geologists believe the ridge was torn from its moorings between Eurasia and North America by the forces of seafloor spreading, causing it to subside and be flooded by the encroaching ocean. This geological history has ignited more than just scientific interest. The ridge sits at the center of immense territorial claims, with nations like Russia, Canada, and Denmark submitting arguments to the United Nations that this underwater structure is a natural extension of their own continental shelves. This has created a unique and tense arena where international law and groundbreaking science intersect, forcing a rare cooperation among rival nations to map and understand this lost world. The Lomonosov Ridge stands as a crucial piece of evidence in the story of our shifting poles. Its existence and the fossils it contains are key to modeling how the Earth's crust has moved over millions of years, helping scientists track the ancient wanderings of the magnetic North Pole. This polar bridge, now fractured and drowned, offers a glimpse into an Arctic that was once green and connected. As we leave the frozen secrets of the North, our journey dives into the warmer, clearer waters of the Atlantic, where another sunken giant tells a story of a different kind of continental drama. West of the stormy coasts of Ireland, a hidden piece of the Atlantic floor holds the key to an ancient continental divorce. This is the Rockall Plateau, a vast, shallowly submerged platform of continental crust that has long baffled scientists. For years, its true nature was obscured by the wild, unpredictable seas that rage above it, but persistent marine surveys have finally mapped its ridges and basins in stunning detail. The resulting images reveal a landscape that was once dry land, a terrain carved by rivers and covered in forests. The proof lies in the rocks themselves. Dredgers have pulled up chunks of granite and sandstone from the seabed, continental rocks that are completely alien to the dark basalt of the deep ocean floor. Even more telling are the discoveries of fossilized wood and pollen grains, preserved for millions of years in the deep, confirming that this was once a living, breathing world. How did this land sink? The story is written in its structure. The plateau is scarred by deep rift basins, evidence of the titanic forces that pulled it apart. As the North Atlantic Ocean began to open, the crust here stretched and thinned like warm taffy, causing the center of the plateau to founder and sink beneath the waves. Only its highest, most resilient edges remain near the surface today. Researchers who study this region are a special breed of scientist, enduring brutal weather and weeks at sea to recover a single precious core sample from the seabed. They speak of the moment the drill brings up a cylinder of sediment, a time capsule that might contain the pollen of an ancient tree or a mineral that reveals the climate of a lost age. Each sample is a clue, helping to reconstruct the ecosystems that thrived here and the precise timing of the Atlantic's birth. This Atlantic enigma, a land now defined by its absence, beckons us toward a continent that is not just a geological wonder, but a place forever tied to human legend and myth. The legend of Atlantis has haunted our imagination for thousands of years, but what if this story holds a kernel of geological truth? Plato's tale of a sophisticated civilization vanishing beneath the waves in a single day and night is often dismissed as pure fiction. Yet scientists have uncovered evidence of real cataclysms that could have inspired such a powerful myth. One compelling theory points to the volcanic island of Santorini in the Aegean Sea. Around 3,600 years ago, this island, then known as Thera, was the heart of the Minoan civilization. It experienced one of the largest volcanic eruptions in human history, an explosion so violent it shattered the island and generated a colossal tsunami that ravaged the nearby coast of Crete. Core samples drilled from the seabed around Santorini contain thick layers of volcanic ash and pumice, a stark testament to the eruption's scale. In coastal sediments on Crete, geologists have identified unusual deposits of marine sand and shells far inland, clear evidence of an ancient mega-tsunami that swept across the land. Historians suggest that the memory of this disaster, which crippled a dominant Bronze Age culture, could have been passed down through generations, eventually evolving into the story of a lost continent. Another theory connects Atlantis to the much later flooding of Doggerland. The Storiga slide tsunami that drowned that North Sea plain around 8,200 years ago was a real event that submerged a vast inhabited landscape. The sudden loss of such a known world could easily have become the stuff of legend. A prominent geologist who studies these events remarked that we must remember that ancient storytellers did not have our scientific vocabulary. They explained world-shattering events through narrative, transforming a volcanic eruption or a tsunami into the wrath of the gods sinking an entire continent. This blend of fact and fiction challenges us to think critically about the stories we inherit. It suggests that our oldest myths might not be histories of specific places, but rather powerful echoes of real human experiences with the awesome, destructive power of our planet. The search for Atlantis, therefore, is not about finding marble columns on the seafloor, but about understanding how humanity processes collective trauma. This journey from myth to measurable evidence leads us to other sunken realms, where the line between legend and geology becomes even more intriguing. The concept of a continent can be as fluid as the ocean itself. Argoland presents a radical departure from the classic image of a single, sunken landmass. This was a continent that did not simply sink but instead shattered and drifted apart. Around 150 million years ago, a massive piece of land broke away from the northwestern coast of Australia. But this fragment did not remain intact. As it drifted northwestward toward Southeast Asia, powerful tectonic forces began to pull it to pieces. Plate reconstruction models, which are like time-lapse maps of the Earth's crust, show this journey not as a solid block moving across the globe, but as a cloud of continental fragments dispersing like a flock of birds. The evidence for this incredible voyage is not found on any map of the ocean floor, but deep within the geology of islands like Borneo and Java. Seismic imaging, which uses sound waves to create pictures of the subsurface, reveals that the rocks beneath these islands have a distinct continental signature. They are not the dense basalt of the deep ocean, but lighter granites and sedimentary rocks that once belonged to a larger landmass. Geologists face an immense challenge in tracing Argoland's path. One researcher compared it to trying to reassemble a billion-year-old jigsaw puzzle after the box has been dropped and the pieces scattered across a room. The original continent was likely stretched and torn into a vast archipelago of smaller microcontinents, which were then accreted or plastered onto the existing edge of Southeast Asia. This process of dispersion and accretion is a fundamental way in which continents grow and change at their margins. The story of Argoland forces us to expand our definition of a lost continent. It was not drowned but disassembled, its pieces now forming the very foundation of a completely different part of the world. This tale of a continent pulled apart by tectonic forces finds a remarkable parallel in another landmass, one that broke away from a different supercontinent and embarked on its own solitary journey. The Mediterranean sun now warms rocks that were once part of a forgotten continent. Greater Adria was a vast landmass, roughly the size of Greenland, that vanished beneath the waves of a prehistoric sea and was later plastered onto the underbelly of Europe. For over a century, geologists were puzzled by the strange rock formations found throughout southern Europe. In the mountains of Italy, Spain, and Greece, they would find layers of limestone that clearly formed in a shallow, tropical sea. Yet these same rocks were now crumpled and thrust high into the sky, forming the peaks of the Alps and the Apennines. The story these rocks told was chaotic and seemingly impossible. The key to solving this Mediterranean mystery lay in a force invisible to the naked eye, the fossilized magnetism locked within the stone. As volcanic rocks cool, magnetic minerals inside them align with the Earth's magnetic field, effectively recording their latitude at the time of their formation. By analyzing the paleomagnetic data from outcrops across the region, scientists could reconstruct Greater Adria's epic journey. It began as a splinter of the supercontinent Gondwana, breaking away from what is now North Africa over 200 million years ago. For millions of years, this continent drifted northward across the ancient Tethys Ocean, a world of shallow seas atop its crust. Its destiny, however, was a collision. As it approached the southern edge of the European plate, it was not met with a head-on crash, but with a subduction zone. The dense oceanic crust of the Greater Adria plate was forced to dive beneath Europe, a process that scraped off the continent's upper crustal layers, its shallow marine sediments and limestone cap. One geologist who spent decades mapping this complex history described the experience as trying to reassemble a giant geological car crash. He recounted studying beautiful limestone outcrops in the Italian Dolomites, knowing that these rocks were essentially the scraped-off paint and sheet metal of Greater Adria, crumpled and folded as the main body of the continent slid into the mantle. The Alps and other ranges are therefore not built from European bedrock, but are largely composed of the recycled remains of this lost continent. The core of Greater Adria was completely subducted, sinking hundreds of kilometers into the Earth's mantle, while its skin was smeared across Europe to form new mountains. This Mediterranean tale reveals a profound truth about our planet's dynamism. Continents are not always drowned. They can be consumed, their very substance recycled into entirely new landscapes. This cycle of creation and destruction leads us to search for other lost worlds, particularly in the vast and turbulent southern hemisphere. The story of Lemuria reveals how scientific ideas can evolve from myth into measurable reality. In the 19th century, biologists faced a puzzling distribution of lemur fossils, found in Madagascar and India but nowhere in between. To explain this, a few scientists proposed a lost continent, which they named Lemuria, that had once bridged the Indian Ocean. This land bridge, they argued, allowed the early primates to migrate before it sank beneath the waves. For a time, this theory was taken seriously, and Lemuria even appeared on some academic maps. But the concept was soon co-opted by spiritual and occult movements, who transformed it into a mythical paradise for a lost race of people, a story that captured the public imagination far more than the original scientific hypothesis. How does modern geology view this legendary land? The theory of plate tectonics provided the real answer. It showed that Madagascar and India were indeed once connected, but as part of the supercontinent Gondwana. They drifted apart as the Indian Ocean opened, a process that required no vast sunken continent to explain the lemur distribution. The animals were simply stranded on separating landmasses. Yet, science has a way of finding truth in unexpected places. While the classic Lemuria was debunked, the discovery of microcontinents like Mauritia proved that the Indian Ocean floor is indeed littered with submerged continental fragments. These are not the single landmass of legend, but the shattered pieces of that ancient Gondwanan connection. A prominent geologist noted that this is a beautiful example of how science self-corrects. We started with a speculative land bridge to explain animal migration, and we ended up with hard evidence for dispersed continental fragments that explain the geology. A biologist added that our job is to follow the evidence, even when it leads away from a compelling story. The journey of the Lemuria theory teaches us that our understanding of the planet is always being refined. It is not that the old ideas were foolish, but that new tools and evidence allow us to see a more complex and fascinating picture. This reflection on scientific progress leads us to a lost continent whose story is still being written, buried under the ice of the Southern Ocean. Rising from the turquoise waters of the Indian Ocean, the Seychelles Islands are a geological paradox. These idyllic landscapes are not volcanic islands born from the ocean floor, but the exposed peaks of a true microcontinent, a fragment of ancient crust adrift in a vast sea. Beneath the waves, their true scale is revealed in massive granite plateaus that stretch for hundreds of kilometers, a type of rock that simply does not form on the standard oceanic crust. This continental origin was confirmed by ships that drilled into the submerged plateaus, pulling up cores of pink granite identical to that found on the mainland. From orbit, satellites measured the area's gravity field, detecting a significant anomaly caused by the thick, buoyant continental crust lurking beneath the light oceanic waters. The story, however, is written in more than just rock. The drill cores also contained fossils of ancient life, including the remains of coastal plants and animals that could only have lived in shallow seas or along the shores of a much larger landmass. These are the ghosts of a lost connection, proving the Seychelles microcontinent was once a solid part of the supercontinent Gondwana, firmly wedged between India and Madagascar. When India broke away and began its northward journey, this block was left behind, a solitary piece of continent stranded in the open ocean. This long isolation created a living laboratory for evolution. Ecologists studying the islands are constantly astonished by the unique species that evolved here, from the iconic coco de mer palm with its giant, suggestive seed to the Seychelles sheath-tailed bat found nowhere else on Earth. These life forms are a testament to the biological significance of these submerged worlds. A lost continent is not just a collection of sunken rocks, it is a potential cradle for life, an isolated ark where evolution can experiment freely. The biodiversity we find on its remaining peaks is merely a hint of the unique ecosystems that may have thrived across its now drowned plains. This theme of isolation and unique life extends far beyond these tropical waters, all the way to the frozen frontiers of our planet. Antarctica's icy fortress hides a secret coastline beneath the Southern Ocean's swell. The East Antarctic Peninsula is not just a finger of land we see on maps, but the visible tip of a much larger continental shelf now drowned under deep water. Ice-penetrating radar and shipborne sonar have mapped this submerged extension in stunning detail, revealing the contours of a lost world buried under sediments and ice. This was not always a frozen realm. Sediment cores drilled from the seabed just offshore tell a breathtaking story. Scientists have pulled up layers of mud that contain the fossilized pollen of ancient rainforest trees, along with fragments of wood and even dinosaur bones. These fragile remains are the undeniable proof that Antarctica was once a green and vibrant continent, home to forests and roaming giants millions of years before the ice took hold. One paleoclimatologist who studies these cores remarked that holding a piece of fossilized Antarctic wood is a humbling experience. It is a direct connection to a world so different from our own, a world without ice at the poles. These finds are not just geological curiosities, they are critical data points for supercomputer models that simulate Earth's past climate. Understanding how Antarctica transformed from a temperate habitat to a frozen desert helps scientists predict how our current ice sheets might respond to modern global warming. The dynamics of these immense ice masses, their stability, and their potential for sea level rise are all written in the history of this lost continental shelf. This story of a frozen continent that was once green seamlessly connects to the saga of another southern giant, a land that broke away from Antarctica and embarked on a long, lonely journey north. South of New Zealand, the ocean hides a colossal shoulder of continental rock known as the Campbell Plateau. This is Zealandia's forgotten southern neighbor, a sunken realm larger than many countries. Though it lies over 1,000 meters beneath the stormy Southern Ocean today, its flat-topped peaks and broad basins tell a clear story of a land that once basked in the sun. Scientific drilling expeditions have pulled up the proof from the deep, core samples containing the fossils of ancient land plants and the unmistakable sands of a long-vanished shoreline. These are not the remnants of a deep-sea environment, but of a terrestrial landscape that was slowly, patiently claimed by the sea. The plateau's isolation created a unique underwater world, a haven for life adapted to the cold, dark, and immense pressure. Marine biologists working with geologists have discovered fields of deep-sea corals that build towering structures on the plateau's ridges, creating oases of biodiversity in the abyssal plain. Strange, ghostly white fish and dense swarms of crustaceans thrive in these cold water gardens, an ecosystem sustained by the powerful currents that sweep nutrients across this submerged continent. Mapping this vast area is a monumental task. Researchers on months-long voyages share stories of deploying remote-operated vehicles into the churning sea, watching their screens as the vehicle's lights reveal a hidden topography of dramatic canyons and sheer cliffs carved by ancient rivers and shaped by millennia of relentless ocean currents. One scientist described the moment a sonar map resolved on their screen, showing the clear path of a drowned river valley winding across the plateau's expanse. It was, they said, like seeing the ghost of a landscape, a river that once flowed under an open sky, now guiding deep-sea currents in perpetual darkness. The silent, enduring secrets of the Campbell Plateau remind us that continental fragments are not just geological curiosities. In the planet's most remote ocean basins, they become the foundations for entire worlds of life we are only beginning to understand. Massive coral reefs thrive on a sunken plateau in the Indian Ocean, their growth dictated by an ancient rhythm of emergence and drowning. This is the Mascan Plateau, a 2,000-kilometer-long submerged shoulder of continental crust that is a geological sibling to the Seychelles. Its highest points pierce the surface to form the idyllic islands of Mauritius and Réunion, but these volcanic peaks are merely the most recent additions to a much older foundation. The plateau itself is a relic, a fragment of continental granite that was left behind as India raced northward millions of years ago. Its history is written in the layers of coral that cling to its slopes. Scientists drilling into these massive reefs have found a clear pattern. Thick layers of coral that grew in shallow sunlight are abruptly capped by periods of deep water sediment, a cycle repeated over and over. This record reveals that the entire plateau has bobbed up and down like a vast elevator, repeatedly emerging as a large, shallow archipelago before sinking back beneath the waves. These dramatic shifts were driven by the interplay of volcanism and erosion. As volcanic hotspots like the one that built Réunion poured out lava, they would add weight to the crust, causing the plateau to slowly subside. Then, during ice ages when sea levels dropped, the entire structure would be lifted into shallower water, allowing new coral reefs to colonize its sun-drenched platforms. One oceanographer who studies the region describes the plateau as a pump for marine life. When it was exposed, it was a huge oasis of shallow seas, and when it sank, it became a deep water refuge. This constant change created a unique engine for biodiversity, forcing species to adapt, migrate, or perish. The plateau's sheer size and changing topography have a profound effect on the ocean itself. It acts as a massive barrier that deflects the major currents of the Indian Ocean, creating swirling eddies that concentrate nutrients and draw in migratory species from thousands of miles away. Whales, giant tuna, and sea turtles all use these underwater mountains as a navigational waypoint. This lost continent, therefore, is not a dead relic. It is a dynamic, living system that continues to shape the ecology of an entire ocean. Its story of a landmass that breathes with the rhythms of the climate prepares us for our final discoveries, where the vast Pacific Ocean holds the ultimate secrets of Earth's vanished land. The vast Pacific holds a submerged ribbon of continent known as the Lord Howe Rise. Stretching from the eastern coast of Australia toward New Zealand, this enormous underwater plateau is a true continental fragment, a piece of real estate larger than California, now lying more than a kilometer beneath the waves. Its identity was confirmed not by a single discovery, but by a chorus of evidence. Research vessels have dredged its submerged slopes, bringing up chunks of granite and sandstone, rocks that speak of a continental past entirely distinct from the volcanic basalt of the deep ocean floor. Seismic profiles, which are like sonograms of the Earth's crust, reveal the rise's true foundations, showing a thick, buoyant layer of continental crust that extends for hundreds of miles. This lost ribbon was once solidly attached to Australia, a natural extension of its eastern highlands during the age of the supercontinent Gondwana. As the Tasman Sea began to open some 80 million years ago, the crust here stretched and thinned, causing this entire block to slowly sink. The most haunting evidence of its terrestrial past comes from core samples that contain the remnants of ancient river deltas and even coal seams. Coal forms from compressed plant matter in swampy environments, meaning this sunken plateau was once a lush, vegetated landscape crossed by flowing rivers, a world of greenery now preserved as a black line in a cylinder of rock pulled from the abyss. Geologists studying the region note that the rise is more than a fossil. One researcher explained that this submerged landmass directly shapes the ocean we see today. It acts as a massive underwater barrier, deflecting deep ocean currents and forcing nutrient-rich waters to rise toward the surface. This upwelling process fuels immense plankton blooms, which in turn support some of the Pacific's most productive fisheries. The lost continent, therefore, is not a relic. It is an active, living part of our planet's circulatory system, where geology directly creates the conditions for life. The hidden contours of the Pacific seafloor, shaped by these sunken lands, lead us to a final, crucial question. How do scientists actually map these invisible worlds and piece together their ancient stories? The deep Arctic holds a final lost continent, a sliver of the ancient world known as the Yermak Plateau. North of the Svalbard archipelago, this massive underwater platform lies under perpetually shifting sea ice, a place of eternal twilight and extreme cold. For years, its identity was a matter of fierce scientific debate. Was it merely a thick pile of lava or a true fragment of continental crust? The answer came from the rocks themselves, gathered by robotic submersibles that braved the darkness and by icebreaker ships that drilled through the frozen surface. Analysis of these samples revealed the plateau's true nature. It was not built from oceanic basalt, but from continental granite, a clear sign it was once part of the nearby Barents Sea shelf. Magnetic surveys added further proof, showing patterns in the seafloor that matched the magnetic signatures of the surrounding continental margins. This was not a newborn volcanic structure, but an old, sunken piece of a familiar land. The discovery of the Yermak Plateau as a continental fragment has ignited more than just academic interest. Its sedimentary layers are now believed to hold vast reserves of oil and natural gas, placing this remote, frozen world at the center of a new geopolitical and economic frontier. Polar scientists who work in this environment describe a research landscape as challenging as any on Earth. They deploy autonomous underwater vehicles through narrow cracks in the ice, listening for their acoustic pings as they map a seabed no human eye will ever see. They speak of the profound irony that climate change, while a global threat, is temporarily making their work easier. The rapid retreat of Arctic sea ice is opening new windows for their ships and robots, allowing them to gather data that was simply unattainable a generation ago. One researcher noted that every mission feels like a race against time, not just to understand this lost continent, but to document a pristine environment that is changing faster than we can map it. The Yermak Plateau stands as a powerful symbol of this new era of discovery, a reminder that the final frontiers of our planet are not in space, but here beneath the icy waves. As we complete our survey of these 20 lost worlds, we are left with a single, profound question that ties them all together. The final lost continent on our list is a sunken savanna of staggering scale. In the remote expanse of the Indian Ocean lies the Saya de Malha Bank, the largest submerged oceanic bank on Earth built upon a foundation of continental crust. During the last ice age, this was not a seascape but a landscape, a vast, grassy plain stretching for thousands of square kilometers above the waves. The evidence for this terrestrial past is pulled directly from the seabed. Core samples, long cylinders of sediment extracted by research vessels, contain layers of ancient soil and the fossilized pollen of grassland plants. These are not the remnants of a marine environment, but of a terrestrial ecosystem that once supported massive animals. The presence of these grassland fossils strongly suggests this sunken bank was a habitat for now extinct megafauna, a lost Serengeti silently resting a kilometer beneath the ocean surface. Modern explorers of this region are not just geologists, but marine biologists drawn to its most famous feature. The Saya de Malha Bank is now home to the most extensive seagrass meadows on the planet. Scientists who dive here, even via remote-operated vehicles, describe an underwater prairie of breathtaking beauty, where dense stands of seagrass sway in the currents, creating a vital nursery for fish, sea turtles, and dugongs. These meadows are not merely a habitat, they are a powerful ecological engine. They act as a massive carbon sink, locking away atmospheric carbon in their roots and the surrounding sediments at a rate that rivals terrestrial rainforests. This final lost continent, therefore, offers a profound lesson. The ghost of that ancient savanna directly enables the thriving marine ecosystem we see today, demonstrating how the geological past continues to shape the biological present. The Saya de Malha Bank stands as a quiet testament to the enduring and often beautiful legacy of Earth's vanished lands. These 20 lost continents are far more than sunken rock. They are the missing chapters of our planet's biography, forcing a complete rewrite of Earth's history. The discovery of Zealandia and its kin fundamentally redefines the very map of our world, revealing that continental crust is not confined to the familiar 7 landmasses but is often hidden, shaping the ocean floor in ways we never knew. The shattered trail of Argoland and the consumed bulk of Greater Adria show us that plate tectonics is not a neat process of moving jigsaw pieces, but a violent drama of creation, destruction, and recycling on an epic scale. The green fossils of Antarctica and the drowned savannas of Saya de Malha provide undeniable proof of our planet's dramatic climate swings, offering critical data for predicting our own future in a warming world. And the human pathways across Doggerland, Beringia, and Sundaland illustrate that our own story is deeply interwoven with these vanished lands. Our species spread across the globe by following coastlines and plains that are now utterly lost to the sea. This entire new field of knowledge was unlocked by a technological revolution. Advanced multi-beam sonar now paints high-resolution portraits of the seafloor, revealing drowned river valleys and sunken mountains. Scientific drilling ships plunge their bits into the abyss, pulling up core samples that act as time capsules, preserving ancient pollen, fossilized wood, and even coal from lost forests. From orbit, satellites measure minute gravitational anomalies, betraying the presence of dense continental slabs hidden beneath the lighter ocean crust. One marine geologist intimately involved in this work recently shared an exciting prospect, stating that the next frontier is deep-sea archaeology. We are now developing the tools to search for the campsites and artifacts of the people who once lived in places like Doggerland, to find the human stories written on these lost continents. This leads to a pressing, reflective question for all of us. If we now know that sea level rise has drowned entire continents and displaced human populations in the past, what does that tell us about the potential fate of our own coastal cities today? The fate of these lost worlds is not just ancient history. It is a powerful cautionary tale written in stone and sediment, urging us to understand the profound and lasting changes we are unleashing upon our planet's geography. Each discovery peels back another layer, revealing a planet that is more dynamic, more mysterious, and more interconnected than we ever dreamed. From sunken savannas to shattered supercontinents, this journey across 20 lost worlds reveals a planet in constant, dramatic motion. We began with a simple question: how could entire continents vanish, and found answers written in stone, fossil, and magnetic field. The story of these submerged lands is not one of myth, but of measurable science. Advanced sonar maps their drowned river valleys, deep-sea drills pull up their ancient soils, and satellite gravity meters trace their hidden outlines. This evidence has transformed legendary places like Lemuria from speculative fantasy into a nuanced understanding of how microcontinents like Mauritia truly did fragment and sink. The unifying force behind nearly all of these stories is plate tectonics. This single, powerful theory explains how a continent like Greater Adria could be consumed by the Earth's mantle, while another like Zealandia could simply stretch and sink. It shows us that the familiar map of our world is just a temporary snapshot. Continents are not fixed, but are constantly drifting, colliding, and tearing apart in a cycle that has repeated for billions of years. These lost worlds also hold critical lessons for our future. The fossilized rainforests of Antarctica and the drowned grasslands of Saya de Malhabank are stark reminders of how profoundly our climate can shift. They show us that sea level change is not a new phenomenon, but a powerful force that has repeatedly reshaped the planet's coastlines and drowned its continents. Understanding how these ancient lands responded to warming and cooling helps scientists create better models for what might happen to our own world. Perhaps the most profound connection is to our own history. We now know that the first Americans spent generations on the continent of Beringia, and that early explorers walked across the vast plains of Sundaland. Human prehistory was written on lands that are now at the bottom of the sea. Our ancestors looked out upon shorelines and landscapes we can only reconstruct with technology. This changes our perspective, reminding us that our time on this dynamic planet is brief, and that the ground beneath our feet is far less permanent than it appears. The exploration of these hidden continents is far from over. Each new survey ship that sails and every new core sample pulled from the abyss adds another piece to the puzzle. Who knows what other lost worlds are waiting to be found, or what secrets they hold about the origins of life, the history of our climate, and the epic journey of humanity itself. We would love to hear which of these 20 lost continents captured your imagination the most. Was it the human story of Doggerland, the volcanic fury that built Kerguelen, or the continental divorce that created the Mayen microcontinent? Let us know in the comments and subscribe to continue exploring the deepest mysteries of our incredible